Hey everyone, it's me. Today I'm going to take you through the notes for acids and bases, introductory notes for acids and bases. Acids. Acids are very common in everyday uses. You use them all the time. I'm going to give you a couple of examples of acids that you use all the time, such as carbonic acid. Carbonic acid is found in pop. Another acid that you might find in food is ascorbic acid. Ascorbic acid is necessary for proper dietary function. It is known as vitamin C. Acetic acid, you have seen before in our classes. Acetic acid is household vinegar. And so you can see acids are used mostly in food purposes for flavoring and cooking. But acids can be very, very dangerous. They're used in industrial productions and at high concentrations can be incredibly dangerous to you. And so let's talk a little bit about what an acid is, what its definition is, and then we'll get into how to name acids. What you need to know, first of all, is acid's definition. Now, there are many different ways to define acid. An acid definition can be very basic and be very complex. The most complex definition of acids are covered in AP chemistry and honors chemistry. And if you're really interested in that, it's something you might want to think about for next year. It's not too late to join AP chemistry. But I'm going to give you the basic definition of what an acid is. An acid is an ionic substance with hydrogen as, or H plus, as the cation. For example, HCl, HNO3, H2SO4, HF, HClO3. These are all acids. What you see is that they all have H plus at the beginning of them. This is the basic definition of an acid. If you plop these acids into water, you've got a cup of water. If you put HCl into water, it will split up into H plus and Cl minus. All ionic substances, when dropped into water, split up into their ionic, or into their ions. HCl splits up into H plus and Cl minus. A more specific definition of an acid is a substance that, when dissolved in water, increases the H plus concentration. You might hear me talk about this in class. An acid is anything that will increase the H plus concentration in water. And so if you take HF, same thing, H plus, F minus, HNO3, H plus, NO3 minus. Notice that all three of these, we don't care about what's at the end. The negative anion has no effect on the acidity. It's all about the H. Whatever has H in it at the beginning of an ionic substance is an acid. Now, acids are defined on a continuum from weak acids. They're not defined, but they're identified or organized on a continuum from weak to strong. Weak acids on this far side are things like HF, and strong acids over here are like HNO3. Now, what makes a weak acid and a strong acid? Now, contrary to popular belief, it is not based on concentration. Acid strength is not based on concentration. Meaning 1.0 molar HF isn't the same acidity as 1.0 molar HCl. These are not equivalent. Rather, what you need to know about acid strength is this, that the strength of an acid is dependent on how much it ionizes. You might be saying to yourself, well, don't all acids ionize? You put anything into water. You just said like a minute ago that anytime you put an ionic substance into water, it ionizes. Well, it does, but it all ionizes. They ionize at different amounts. Some ionize a lot, and some don't ionize much at all. Here's what I mean. Say you take HF and you put it into water. It dissolves and becomes H plus and F minus. Now say you put 10 of these in, 10 HFs. Now I'm putting out a number here, and it's not very accurate, but for the sake of conversation, this is what happens. For every 10 HFs that go in water, only one H and one F minus, and what you get is 9 HFs that don't dissolve. If you think about it, if you think about the percent ionization, meaning how many HFs ionize, of the total HFs that were put in, only one ionizes. So if you take the H plus concentration over the total HF, you get 1 over 10, because only one H, and you started with 10. So it only has a 10% ionization. That means a weak acid. Low ionization equals weak acid. Now what about strong ionization? Strong acids are identified as things that ionize 100% of the time, which means like HCl. HCl is a notoriously strong acid. 10 HCl molecules go into water. You get 10 H pluses and 10 Cl minuses, and 0 HCl's left over unionized. That means that you have 100% ionization. Remember, if percent ionization is equal to the H plus over total HCl, then I have 10 H pluses over 10 HCl's that went in. That's equaling 100%. Now, for the sake of conversation, this chapter we will only talk about things that ionize 100%. Or in other words, acids, for all intents and purposes for our discussions, are strong. And it's worth noting at this point that if something is not strong, it's weak. So there's no in-between for us. It's strong acids, and it's everything else. So these strong acids are ones that ionize, I'm missing an R in there. Strong acids are things that ionize 100%. HCl, you don't have to memorize these, but here's an example of the ones that do. HNO3, HClO3. Things that are weak ionize less than 100%. Even 90%, you think, oh, 90%, that's an A, if this was a test, but it's not a test. 90% is a weak acid. It's strong at 100% or weak at anything less than 100. Weak equals anything less than 100% ionization. And that equals, strong equals 100% ionization. So weak acids are like HF, H2CO3, H3PO4. These are weak acids. Now some characteristics that all acids share, whether they are strong or weak, are the following. And this is an excellent multiple choice question, so make sure you know these. They all start with H+. Secondly, they're liquid or gas. Now there are some solid acids, but for the most part they're liquids or gases. Now because they are used in food and flavoring, not strong acids, but weak acids. Weak acids specifically are used in things like pop and cooking, flavorings of some sort. They add a sour taste to your food. Lemon juice, lemon juice has citric acid in it. Citric acid has a lemony, soury taste. That's how they get their sour taste. But no matter what, if it's weak or strong, at high concentrations cause severe chemical burns. Now what's tricky about acids is that they're almost all colorless gases or liquids, meaning they look like water. They all look colorless. They're not odorless. They definitely have a smell, but they're colorless. So if you're just looking at something in a beaker and you're like, oh, that looks like water, they're probably not, because it could be an acid. It could be a really strong acid. If you spill it and get your hand on it, it could burn your clothes, burn your skin. Very, very dangerous stuff. Now, if you understand what an acid is, it's very easy to identify what a base is. If an acid is anything that has H plus in it, a base is an ionic substance with OH minus in it. For example, NaOH, LiOH, CaOH2, BaOH2, that's an H. These substances, bases, are any ionic substance with OH as its anion. So when you drop NaOH into water, it dissolves into Na plus and OH minus. This right here is an indication that a base is present. If you see OH as an anion, or OH when it's dissolved, because it's in water now, it's aqueous. Aqueous OH means base is present. Like acids, bases have strength as well, and the strength is not equal to concentration. But rather, the strength of the base, again, is based on percent ionization. It's the how many OHs are made from the total base molecules. So if you've got a strong base, say NaOH, and you put it into water and you get Na plus and OH minus. If 10 of these go in, you get 10 NAs and 10 OHs and 0 NaOH left over. That's a strong base. But if you get a weak base, such as AlOH3, splitting up in Al plus 3 and OH minus, if you put in 10 of these, only one of these forms and one of these forms, you got 9 left, then you only have 1 Al for every 10 AlOH3s. You only have 10% ionization. That is a weak base. Strong and weak are the same for acids and bases. The same principles apply. Like acids, all bases have some general characteristics. More information you need to keep track of. First of all, they all have OH in solution. Second of all, they are solids, almost exclusively. Solid substances. Ionic substances like crystalline powders. Third out of 4, they taste bitter. If you've ever eaten soap, or your parents ever made you eat soap because you swear, the taste of soap comes from its base, its bitterness. Dark chocolate as well. The taste of dark chocolate is because of the strong concentration of OH in the chocolate itself. Finally, also cause severe chemical burns. If you get this on your skin and you leave it there for a minute or two, over time it'll begin to burn and sizzle and crack, and you'll get second-degree burns, blisters, and very, very painful. So bases and acids are not to be messed with. Well, that's it for general characteristics of acids and bases. Hopefully you got a little bit out of this, and I'll be asking a couple questions in class about this tomorrow. So make sure you pay attention to the video, take notes.
That takes care of this video lesson. Thanks for watching.